Hi together. My name is Violetta Schum, and I'm working at the Fraunhofer Institute in Germany and want to give you a short overview about the project Cider. In this project, we're taking care about the circular product design for automotive components made from recycled and sustainable composite materials. The project is being realized with the help of various partners from different countries. In Estonia, we have the Tallinn University of Technology. In Germany, we have the help of the Fraunhofer IGCV, Forward Engineering, Rexhi, as well as Autefa Solutions. In France, we have the help of Arkema, IRT-M2P, and Plastic Omnium. And additionally, in Spain, AUTOTECH Engineering and Gestamp. Cider is funded by the ADEME 3 program and supported by Horizon 2020. The total amount of the project is 1.8 million, with a funding of total 1.1 million euros. And it's running from August 22 to July 24, so we have reached the final phase of the project. But let's talk about the topic of our research project. Carbon fiber reinforced plastics are multi-purpose materials that can achieve high mechanical properties in particular. That's why they're often used in lightweight applications, such as the mobility sector. But there are some challenges. The more material are used for one part, the more difficult it's to separate the individual components afterwards. Also, a large amount of energy is required to produce such composites, especially carbon fibers. In addition, large quantities of various waste products are generated during the production and after the use phase. In several countries, these waste products are still landfilled or combusted, resulting in almost no benefit. The use of composite materials for this purpose is therefore only reasonable if the materials are used efficiently and can be recycled afterwards. And this is exactly what the Cider consortium is committed to. So, what is the main goal of the Cider project? We are trying to develop new sustainable composite materials for the mobility sector. We therefore want to reduce the footprint of carbon fiber reinforced plastics through an efficient recycling strategy. The project key objectives are production of sustainable first life components like hydrogen tanks, a development of a novel recycling approach for an efficient fibermetric separation of these hydrogen vessels, and the further processing of the recycled fibers into semi-finished products, as well as the manufacturing of second life demonstrator parts for closing the loop of circular economy. So, what we have achieved so far and what are the expected outcomes? First, we produced some CFRP hydrogen vessel type 4 tanks with an optimized design for recycling. So no metal parts, only composite materials. Some impressions from plastic Omnium can be seen in the figures on the right. Therefore, we had to adapt the winding process of carbon fibers in combination with the helium resin from Arkema, which in turn enables us to achieve a high level of recyclability. To evaluate the quality of the composite, several burst and cycling tests have been done. After the use of such composites, fibermetric separation is necessary to recycle the tanks. As a first step, we investigated different shredding technologies for this purpose. And high impact milling has shown promising results so far, as you can see on the pictures above made by Taltech. Afterwards, depolymerization is carried out to recover the carbon fibers with 90% of the properties and the purified monomer for further use. To check the properties of the recycled carbon fibers, we're using a single fiber tensile test to compare the strength, stiffness, and the diameter of the fibers. The RCFs are then processed into 100% highly orientated nonwoven products using a special process which consists of a carding machine, a 0-degree lapper, web drafter, and a needling and winding unit from Autefa. The orientation of approximately 3:1 enables anisotropic properties and improved impregnation behaviors. Via eddy current and the mechanical properties of the composites, this kind of fiber orientation can be determined. To close the recycling loop, two different second life demonstrators are produced with the manufactured nonwovens and the helium resin. One door panel from the automotive sector in cooperation with IRT M2P and Gestamp, and a trim skirt for a railway application made by Rexhi. Therefore, RTM and wet compression molding is used for composite manufacturing and being further developed. Different material combinations and processing settings are compared on the basis of several characterizations at nonwoven and composite level. And during the next month, a third live demonstrator will even be produced from the recovered fibers from one door panel and recycled helium resin. So it's going to be exciting. What contribution does the project provide to the recycling of carbon fiber reinforced plastics in the end? The matrix composition was adapted to meet the requirements of the application with the highest possible recycling rate. Also, a LCA of the first live demonstrator, so the hydrogen vessel, to compare the environmental impact of this product. We're also able to give recommendations for suitable shredding technologies for the recycling of such hydrogen tanks. And also the demonstration of RCF applications in the automotive and train sector. Within the project, we're also considering recycling aspects already in the product design. For example, with reversible connections of several components. And finally, we're creating guidelines for the further processing of RCF-based nonwovens with RTM and wet compression molding. And now I want to thank you for your attention. I hope I was able to give you a brief insight into our project around the composite recycling, and I look forward to sharing some more information in the future. If you want to contact us, you can take a look at this slide. And at the end, I want to give many thanks to our funding organizations and wish you a good week. Bye bye.